Hexa company was established in 1997. Our experience in engineering computations has only grown since, while our confidence in correctness of the chosen approach has only strengthened. Today, engineering computations are a necessary support for any scientific and technical solutions, especially for unique and innovative ones. Disregard of or saving on timely computations often resulted in deplorable consequences, rarely without human casualties, let alone economic losses. The Hexa company offers support in solution of engineering tasks of any degree of complexity. Today, we have broad experience in such production sectors as machine building, construction, biomedicine, and transportation. Competent specialists of the company use up-to-date techniques from the field of mathematical modeling of physical processes. In construction, the Hexa company commonly offers two main types of work. The comprehensive engineering analysis of structures may include, depending on the preferences of the customer and recommendations of the company's specialists, the following types of work: checking calculations, computation support, design, computations of structural components, load and impact computation. Due to a specific character of its work within the framework of existing normative documents base and limitation in the facilities used, an ordinary designer has no opportunity to take account of all design features of a unique structure. However, the specialists of the company employ their knowledge in the fields where such skills are not commonly required, but a need to use them is shown not only by accidents but also by customers. The loading-carrying ability analysis of the ice arena in Kolomna showed a need to make significant structural changes. A computational model of bearing structures included a detailed three-dimensional description of behavior of all structural components. It is hard to overestimate an economic effect of timely changes made on the basis of our computations. The facility, valued at $200 million, was saved from destruction. The appearance of local bulges in the upper layers of roof covering of the ice arena during further service showed that the analysis based on normative documents and often employed by designers was reduced. Employing the techniques of a traditional approach to computations with the use of simplified mathematical models, they could not take into account features later found by the specialists of the Hexa company by means of additional aerodynamic evaluation of wind impact. Finally, it became necessary to replace the roof covering, which could have been prevented by spending significantly smaller amounts of money on computational overhead. The use of computation techniques, which make it possible to consider almost any nonlinear features in behavior of reinforced concrete, is the need of today. The company successfully, with recognition in state expert examinations, realized its approaches in modeling of reinforced concrete structures by example of such works as checking calculation for constructions of the ice arena in Angarsk. The facility is located in the earthquake-prone region. Design of lining 5.8 meters in diameter for the underground railway tunnel in Nizhny Novgorod. Computational models of the mentioned facilities considered a spatial arrangement of reinforcing steel in reinforced concrete structural elements and physical nonlinearities during the operation of reinforced concrete elements. Load and impact computation is one of the main stages determining the correctness of the construction projects in its entirety in the future. In the process of development of unique construction projects, designers often deal with loads and impacts for which there is no substantial description of computation techniques in the standard specifications or in scientific and technical literature. Thus, in the analysis of bearing structure strength for a pontoon of oil tank 20,000 cubic meters in volume, it became necessary to assess the impact of air bubble coming to the surface from the bottom of the tank when a filling tube was purged. The company's specialists computed the loads produced by such impacts with the use of a fluid mechanics apparatus. The obtained results provided a detailed insight into estimated loads on the pontoon structure. In the design of tunnel lining, the company's specialists employ ground load computation techniques with the use of both two-dimensional and spatial three-dimensional models. Both layer structure of ground and pressure of underground waters are taken into consideration. The company is experienced in determining loads on the tunnel shield in the process of underground tunnel drilling, including an inclined one. In addition to the comprehensive engineering analysis of structures, the company is experienced in works related to assessment of accidents and man-made disasters. Such works can be divided into two types: inspection of structures for conformance to normative documents and analysis of contingencies and structures' operational conditions. The analysis of loading carrying ability of the collapsed roof of Transvaal Water Park, when 28 people died and more than 100 people were injured, which was carried out by the company for the purpose of assessing the conformance of the structure to the normative documents with a view to its strength, showed a complete inadequacy or non-conformance of the project. However, the project had passed all stages of expert examination at its time and had functioned for some time before the accident. The company's wide experience in many fields where engineering computation with the possibility to build detailed mathematical models is needed gives it an opportunity to participate in the assessment of accident and man-made disasters almost in any field of science and engineering. Thus, using its knowledge and experience, Hexa specialists analyzed the causes of derailment of the Nevsky Express traveling from Moscow to St. Petersburg on November 27, 2009. There were built detailed models of the train's movement in the area, a detailed model of elements of the upper railway structure, and a railway infrastructure. Passengers in the models were represented by virtual anthropomorphic dummies with respective physical parameters. The results of such detailed modeling make it possible to draw definite conclusions concerning the causes of a large number of human casualties, dozens, in this accident. The so-called cascade seat stare-off in one of the rail cars, which crashed to the ground at its full speed, resulted in such large number of victims. In addition, the company's specialists showed, using the obtained mathematical models, that it was possible to adjust the structure in accordance with the necessary requirements for its safety. In particular, there was developed a simple structural solutions which increased the strength of passenger seats more than 3 times. With the use of such structural solution, the number of victims could have been smaller. Anticipation and analysis of contingencies at the stage of design and development make it possible to avoid costs of rectification of the consequences of accidents. Our company transforms the experience of today's tragedies into more safe structures of tomorrow.